Okay, so what if we would like to add or subtract matrices or multiply a matrix by a scalar value? So if we want to add or subtract them, what we need first of all, two matrices of the same size. So that is key. They have to have the same dimensions in order to be able to add or subtract them at all. If they don't, then you cannot do this. If they are, then you basically just add or subtract the corresponding entries in the two matrices. So they have to be the same size so that they have corresponding entries. They do follow a few of the laws for addition, which is that matrices can be added in either order, and you can get the same answer from that. So they follow the commutative law for addition. They also follow the associative law for addition, which is that basically you can do them in any order you want. You can add two and then a third, or you can add the second two and the first, and it doesn't matter as long as you're adding. You can add in any order that you want. If C is some real number, you can take a number times an entire matrix by just multiplying every entry of that matrix by that number. And one more definition before we get started on some examples is that you can find what's called the transpose of a matrix by reversing all of its rows and columns. So taking an M by N matrix and reversing it entirely so that it is now an N by M matrix. So you interchange again the rows and the columns. Okay, so let's dive into a few examples here. We've got matrices A, B, and C, and our first goal here is to show that A plus B equals B plus A. So let's show that that commutative property holds. Okay, so we're first going to do A plus B. This means to take matrix A, 2, 1, 3, negative 2, 1, and 0, and add that to matrix B. When we're adding, we just add the corresponding entries. So I want to add 2 plus negative 1. I want to add 3 plus 3, 1 plus 2, 1 plus 2, negative 2 plus 0, 0 plus 4. I'm going to drop down below to give that final solution because I can make it a little bit smaller now. So 2 plus negative 1 is 1, 3 plus 3 is 6, 1 plus 2 is 3, 1 plus 2 is 3, negative 2 plus 0 is negative 2, and 0 plus 4 is 4. So there is A plus B. Let's check out B plus A now. So what if I reverse these? The claim is that that does not actually change the answer. What if I take B first and then add A to it? I think we can pretty easily see that since adding in either order without a matrix is commutative, adding inside of the matrix is also going to be commutative because I'm going to get the same additions just in reverse. So dropping down below, I get the exact same entries. So I have shown here that A plus B equals B plus A. So we can rest assured that that commutative property does still hold for adding matrices. Now, we may be wondering, does it work for subtraction? Can I subtract matrices in either order and get the same answer? So first let's do A minus B, and then let's do B minus A and compare. A minus B, I'm just copying down my matrix from above. This time I'm subtracting. The key with subtracting, and I'm going to rewrite this problem. I recommend doing this, especially when you're first getting started with these, to make sure you don't make any mistakes. The same idea goes with matrices as with regular numbers, which is that subtracting is simply adding. I can change this to an addition problem. It's adding all of the opposites. So I could change this to a positive 1, a negative 3, a negative 2, negative 2, 0, and negative 4. I can basically apply that negative sign right here to make all of the values in the second matrix their opposite. So I applied the negative to a negative 1 and got a positive 1. Applied it to a 3 and got a negative 3. So you can see how that works. If I write it as an addition problem, it becomes a lot more straightforward to do. So now I can simply add the entries. 2 plus 1 is 3. 3 plus negative 3 is 0. 1 plus negative 2 is negative 1. 1 plus negative 2 is negative 1. Negative 2 plus 0 is negative 2. And it's a really sloppy value there. That's a 0. 0 plus negative 4 is negative 4. Okay, so there we have A minus B. Let's see if we get the same thing when we do B minus A. So what if we reverse it? So let's see, B is negative 1, 3, 2, 2, 0, 4, minus 2, 3, 1, 1, negative 2, 0. I'm going to change that to adding the opposites. So the first matrix stays the same. I'm going to change this to adding, and I'm going to reverse every value in the second matrix. Reverse the signs. And now add my corresponding entries. So negative 1 plus negative 2 is negative 3. 3 plus negative 3 is 0. 2 plus negative 1 is 1. 2 plus negative 1 is 1. 0 plus 2 is 2. And 4 plus 0 is 4. So what we can see is that these are not equal. Subtraction is not a commutative process. It was not with regular numbers, and it still is not when we are dealing with matrices.